All right. Happy to be here again today with the undisputed hydro weight champion of the world, Harley Smith. I'm the organic mechanic with Kelp4less.com. And we've been talking about microbes quite a bit. And I went to a conference and I learned some really unique studies that's going on and some very specific microbes that do very specific things, not in the plants, not in the soil, but they live on the plants. You got to hear this, Harley. It kind of blew my mind. So if you don't mind, I'm just going to get right into it.
It's all yours.
All right. Okay, so I listened to a presenter. His name's Dr. Sands. He was, I believe, with Montana State, I believe, but he had a couple really neat projects he was doing in his education and trying to solve quite a bit of unique problems out there. You know, and in science, as you know, a lot of this stuff starts as a hypothesis, and they start there and see what can happen. But a couple interesting projects he was involved in, he had one called the toothpick project. And they would inoculate a toothpick with a specific kind of fungus that would destroy a noxious weed in Africa. And so they found that was just such a valuable tool because it eliminates, you know, some pesticides, some herbicides, and it's very easy to ship and get those into the producer's hands. And they would just go put toothpicks around where the specific weed was. Just phenomenal thinking there. Phenomenal thinking. And so then I really got my attention. I really started to listen. And then he started talking about this phenomenon that's called biological precipitation. And Dr. Sands went in to discuss there's a specific type of Pseudomonas that lives on the leaves of plants, of growing plants, okay? They actually turn into like little balloons and go into the atmosphere. And this specific strain has a little tail on it that collects moisture. And as it keeps going into the atmosphere, it turns into ice crystals and gets into the clouds. And that's how it spreads itself to other fields and other plants. Now, the look on your face was a look I had too, Harley. And they couldn't figure out. So anyway, they tried to eradicate the species on the plant leaves in their science project. And they felt confident. They treated the seed, they treated the field, that this Pseudomonas wouldn't show up again. Well, guess what? It did. And so that got them thinking, where is it coming from? We know it's not in the soil, it's not in the seed. What's happening? So he explains that he went up in a Cessna with Petri dishes and went up into the air and holding the Petri dishes out the plane to see what, you know, kinds of bacteria and microbes he could collect. And lo and behold, it was a strain of Pseudomonas. So that's what started his whole project of learning about this thing. And it's amazing. And you can find this on YouTube, Dr. Sands, and it's called bioprecipitation, a biological precipitation. Mind blowing. And he gives a very good presentation too that you can go back and watch to, you know, he knows all the fancy words a lot more than I do, but it is very interesting. Have you ever heard of anything like that?
No, I mean, that's a surprise to me. You don't think about bacteria or you know, there is a bacteria, Pseudomonas. You don't think about that being spread by anything but water or maybe whatever other plants. You don't think about it going up into the clouds and precipitating back down in fields, you know, like pollen or dust. Yeah, I guess it'd be interesting. No, I bet there's a lot of, well, I know there is a lot of microbes that live on dust that's in the air. I mean, it's all around us. I mean, if you had a particle counter in your room and just put it up there and held it up, I mean, it's just like a river, like a Geiger counter, just constantly going off because the particles are in the air and it's so easy to get contamination from that. But contamination is one thing, and spread of beneficial bacteria, something you really don't think about that much in the air. I've never thought about it.
Absolutely. And he's showing how this helps create moisture in the air and moisture in clouds. And he had some really unique graphs of snowflakes kind of showing where this microbe is in the snowflake when it freezes. And so
Hmm.
as he goes through his presentation, he's really laying out a plan to really help drought and, you know, to help get more moisture in the air or in the atmosphere or in the clouds, and how the importance of having a growing plant is side by side just as beneficial for drought, to help with the drought, to make more rain, to make more clouds, to make more um, precipitation. Just one function of this microbe, and it's fascinating. I love stuff like that because, again, I've always said, we know so little about what actually goes on in the biological function of soil.
Yeah.
Now we need to look at the air, the biological biological function in the air, and then, like some of the endophytes that live inside plants. It's just, it's so broad. We have so much to learn.
Yeah. Well, we've been concentrating so much on the root zone, the rhizosphere, and appropriately so, because there's so much more we need to learn there and the effect. But yeah, what about, the phyllosphere, the leaf surfaces? The microbes are there too, and they're beneficial. They help protect the plant. There's some of them, the endophytes you're talking about, that are inside the plant, and that really will help to fix nitrogen and phosphorus.
Yeah.
Inside the plant, they make phosphorus more soluble and available. So it's not just the roots. Have you done any studies or done anything with doing foliar sprays of microbes like in your living water where you're spraying the leaves and seeing any effects or
I
tests?
really haven't. I really haven't concentrated on that. We have done that, but as far as testing and formulating and things like that, I haven't. I know there's a lot of products out there that advertise the endophytes that are applied foliar.
Mhm.
Me personally, I haven't went down that road. Um,
Mhm.
I think we have better chances doing it with the water and the soil
Yeah,
of seeing a response that way. There's so many factors when you apply foliars. You know,
that's true.
too hot, too cold, too wet, too dry.
Yeah,
There's just so many factors.
that's a good point too, because a lot of the microbes, bacteria, don't do real well with UV light. They have to be protected. So, yeah, okay, I
Hmm.
got you. Maybe not quite, or at least not as predictable as they would once they're down in the soil and living on the roots in that
Hmm.
zone.
Hmm.
But still there, they do have a function, and there's some microbes that are more likely to survive on the leaves than others over time. So there's some studies that I have because I do my microbiology class that talk about testing the phylosphere and which are the dominant species, which ones are dominant early, which ones become more dominant later. And the
Yeah,
pseudomonads are part of that process.
very
One thing,
interesting.
just one thing about pseudomonads, though, and potatoes, which you might know a little bit about in your area, but
Hmm.
some of the Pseudomonas fluorescens, some of those different strains, specific strains of Pseudomonas, are really harvested from disease suppressive soil. The ones that were they air the fields that showed resistance to some of the diseases from the potatoes. I can't remember what they're called, not the cankers, but something like that affect
Like
potatoes.
the rhizoc, was it rhizoctonia?
No, it's like more like a scab type product
Okay, yeah,
problem.
right. Okay,
Something like
yep,
I wish I
scabs. Yeah.
could remember the name right now. I have it in my notes. But the point was that there were some fields that were resistant. They did not have that problem, even if they weren't using fungicides. And they found they started collecting microbes from that area, and the Pseudomonas fluorescens and a couple other Pseudomonas species were associated with disease repressive soils. So they added those to some of the other blends because you want offense, take up nutrients, you want defense, protect against disease. So if you can get the right team, you have the offense and the defense, it works better than either of those strains alone.
That's right. The biodiversity that keeps everything in check,
Mm-hmm.
keeps everything in balance. That's the important, that we need that biodiversity, that diverse ecosystem, and it keeps everybody doing what they're supposed to do
Mm-hmm.
in the soil. Very important.
As well as in some you don't even know for sure, some of the studies, like you said, science. We're so so new to some of this that we have hypotheses. We know it works. We see it happening, but we're still not 100% sure why. And so
Right,
that,
right,
is it
exactly.
really the microbes themselves that are producing antifungal agents? Yes, we know that does happen. Or is it the microorganisms stimulating the systemic induced response of the plant and the systemic acquired resistance of the plant, stimulating the immune system? So the plant's natural immune system is activated to fight the disease. Or is it both?
Yeah,
And in science, you try to isolate one variable or just one, you're really trying to prove one hypothesis. And sometimes it's not one thing. And and then
exactly.
and that can be a problem too with the science because if you can't really isolate a specific cause, then if you use that one microorganism all by itself, you say, well, it's not, the results vary. We're not getting the same results every time because we don't know. We just really don't know the synergy between the different microbes in the soil,
Yeah,
on the leaf, inside the plant.
exactly. And we touched a little bit on this in a prior podcast a couple of weeks ago, I think, about the VOCs, the beneficial VOCs that go on and can do a lot of what you just described already, that take place so fast it could just be, there for a second. And what does that do to stimulate the plant? Well, there's a lot of unknowns, a lot of holes in that, but we know something's going on.
Yeah. To me, it's exciting. Again, I just it's good to not know everything, and it's good to know that we know more than anyone in history knows,
Yeah,
but we know so little, and that's exciting to me because it'll never get boring. There's always new things to learn, like what you just said from that last conference that you attended about how
yeah,
the
that's
microbes spread on this planet. But I tell you
yeah,
what, though, it does throw up one caution flag to me because everything is so interrelated in our environment, the air, the soil, the water. You know, are we causing pollution in ways that can disrupt this delicate balance over time? Will nature be able to repair itself fast enough? I don't know. So I guess that's one thing I've always in the back of my mind think if we do we know just enough to be dangerous.
I think you're right. Yeah, I think we complicate nature a lot more than we have any idea that we do, just by the times we live in, standard practices and things we do, and what's normal to us. Who knows the impact that it has, little by little by little by little by little, but over time. Yeah, there's a lot to think about in that statement.
I know it's so every time there's a new discovery, it's an excitement, but there should be some caution that comes with that. How do we protect our environment? Not
Hmm.
for the environment's sake, for our sake,
Yeah, that's exactly right. I wanted to touch on another point. You were speaking about something earlier, and we do some specific brews here that we do in the light because we're trying to express the specific species in some of our brews. I'm not going to say exactly what it is because that's kind of a trademark for our company, but Yeah, there's a specific brew that we do in the light, and most of the brews we do in the dark. But if we leave one of our tanks with a light on it that never goes off, it's very interesting to see what develops versus in the dark. So anyway,
Mm,
just another fun thing to do, because I know we have a lot of brewers out there and a lot of people that make their own concoctions. And anyway, that was a learning experience that we never thought about.
mhm. Yeah, I'd like to get your opinion here on not so much, I guess, priorities for the short-term future and into the future. You know, are you are you thinking that the microbiology is going to be the biggest type of advancement in agriculture? Or are you thinking more of the biostimulants? Where are you seeing things going? Because yeah, I know you've done both over the years, a lot of both. Where do you
Mhm.
think the future discoveries or the future lies, in your opinion?
Yeah, in my opinion, and what's getting all the funding now and all the research are biopesticides,
Ah,
biofungicides, because we know we know every time we apply a pesticide, whether it be for weeds, insects, fungus, uh, nematodes, the fumigants, all that stuff, we know there's residual carryover, and and we've known this for a long time because if you're farming, if you use a specific herbicide, you will not be able to rotate into your next crop without it being affected. So it's very specific on what herbicides you can use on certain crops because of the next crop you're going to plant could be affected from the residual. So for
mm,
that reason, there's been a lot of research, a lot of dollars going into the biopesticides, and that's a broad term, the biopesticides. But there's been some big advancements, and they're important. If we can get away from a lot of these synthetics and get more natural solutions, I know it's better for the food being produced. I know it's better for the feed being produced, and we don't have to worry about those long-term residues that show up, years down the road from overuse of pesticides. So, in my opinion, that's the next big wave. And there's a lot of companies doing it now, and it's getting bigger and bigger and bigger. We just need a broader audience to think that way. This is my ground. I want to help preserve it. I want it to become healthier, more productive, and get away from a lot of the pesticide use. So that's my opinion. Kind of a long answer there.
no, that's good. That's what I want. So do you think that's long term, or do you think that's the next wave in the process?
Yeah, I think it's the next wave. I think it's the next wave, and I hope it becomes long term. But it's kind of it's a new field right now, and a lot of the big chemical companies are looking into it too because they're under a lot of pressure for some of the toxins that have been left behind, and a lot of the statements on the label, the warnings and things like that. Almost everyone's toxic to bees and toxic to fish, and
Mm, yeah.
there's so many guidelines on using it. That's what I'd like to see go away, more earth friendly type controls, because when you're farming, especially on a large scale, it is a challenge to get the plants where you need to be on a large scale any given year. Okay. So we always talk about the high bricks, and that's very easy to do on a small scale, or at least we have a
Mhm.
little bit more control. But on a broader scale, if you get an insect infestation on your crop, that's your well being, you have to use an insecticide.
Yeah.
There's just no chance. You can't sit there and see the crop go to waste, even though it may not be good for human consumption. It's just that's where we're at right now. So if we can get away from using those things that kill birds, fish, bees, microbes, and get something more biologically friendly, I hope that's the trend. I hope it continues to grow for the long term.
Okay. Yeah, I know the on the other side of that, if pesticides and them on their own, as you know, that you're accelerating the evolution of the insects when you do
Yeah,
that, right? You
right,
spray
right.
some chemical to kill them. There's going to be a certain percentage of those bugs that are going to make it, that they're more naturally resistant to to the pesticide. Maybe the first time you use it, oh wow, great
Hmm.
results. Look at this. I wiped them out, saved the crop. Yay. Next time you use it, it doesn't work quite as well because the ones that survive, they're the ones that are going to mate and lay more eggs. Those genes are being passed on for literally for pesticide resistance. And then you get to like the third time, it doesn't work at all because you've just bred resistant microbes. So what do? You have to come up with a new pesticide. And
Hmm.
that's just a vicious cycle where if we can do this with nature, they're not going to be able to build up a resistance to nature. Well, maybe to a degree they would, because we're still monocropping and we're still trying to fight the same things over and over again, but it won't be as uh, fast because, like we said, there's multiple effects that the microbes have, like stimulating the immune
Absolutely.
system and making some of these agents. And some of it, they don't even make it unless they're under attack. So we're not just doing a blanket um, spray where it's very
Exactly.
specific for under a specific set of circumstances, and nature's been doing this for a long, long time. Yeah, we might lose some, but we don't lose all if we work with
Yeah.
nature.
This is very common in soil fumigation. That's a lot more common practice than people realize. I mean, complete large field, large soil fumigants. And when they started using these, I don't know, 25, 30 years ago, time goes by so fast I can't remember. Man, did they work great. Like everybody, this is the wave. If you're gonna grow a crop that's below ground, so like onions or potatoes or carrots or no, this soil fumigant, you fumigate the soil before you plant, won't have any problems. All the problems going away. Well, that worked for a couple, 3 years, and exactly what you said. Well, now we're gonna have to put on more to do the same job it did before. So we went through that phase. Okay, now we have a different fumigant we have to use. So we're switching to this one, and that's still evolving, and we've gotten nowhere as far as what we're trying to target in the soil. It's getting worse just because of the reasons that you stated. So we've got to look at biology closer to get us through this. We have to. We have no choice.
Yeah. Well, that was one of the big motivators for me early in my career, because early on we were fumigating with methyl bromide,
Mhm.
which kills everything. I mean, yeah, it'll kill the bad guys. It also kills the good guys. And, by the way, as a nice side effect for nature, it destroys the ozone at the same time. So you get more UV. I mean, which that's not exactly a good thing for the planet Earth. And we were in the United States was one of the few countries, industrialized countries that allowed it because there wasn't an alternative. So when I first started to hear about some of the biostimulants, some of the trials they were doing overseas, that was it. We need this because we can't just keep on doing what we're doing. We cannot do that. We're going to ruin our soil and ruin our atmosphere. We have to find an alternative, and that was a motivator, a big motivator to me at the beginning, early on in my career. And that
Well, good.
was about maybe close to 25, 30 years ago, somewhere in that area. Yeah,
Yeah,
it was 25 years
our
ago.
our time frames are lining up. Yeah, yeah. I gotta throw a shout out to my friends at BioSafe Systems because they've been doing
Oh,
this for a long time in the greenhouse industry. Good
mhm.
people, good products, and they're very like minded as well.
Okay. All right.
Yeah.
Well, I think we're about out of time for today, but thank you for taking the lead today. That was nice. Yeah, there's we can have as many discussions on microbes as you like. If I get a couple minutes early, a little bit to prepare, I can check my notes real quick too, to see some of the. I can get more specific with some of the actual strains, and not just Bacillus subtilis, but Bacillus subtilis, for example, there might be in a blend, there might be 12 different strains of Bacillus subtilis in that one. It's not just one thing, and they all have some of the strengths and benefits. So we could talk about, we can get as down to business as you want in the coming weeks.
All right. What might be fun is trichoderma. Let's take a look at the different trichoderma species.
Oh,
That's a fun one.
yeah, Trichoderma harzianum, Trichoderma hamilton. Those are two of the big ones, and that's one of my favorites too. So we'll talk about that. That's actually a fungi. It's not a
Yeah.
bacteria, but
Yeah.
I included it on my list.
Me too. Yeah. Make it
Okay,
it's part of the ecosystem. Anything we can fit into the ecosystem, let's talk about it. Okay.
okay,
Well, sorry we went over a little bit on your time here. I hope you have a wonderful day.
not a problem. And I will talk to you soon. We won't be meeting next Wednesday, but next Friday, a week from Friday. So
All
I'll
right.
catch up with you then. Have a good one.
Okay. Thank you, sir.
Okay,
See
bye.
ya.